Assalamualaikum. We are now in chapter 11. It's about rational expectation and demand policy. But before we go into detail on the rational expectation itself, then let's look at the meaning of rational expectations. Now, we learn in economic study from the basic itself when in the at the degree level, bachelor degree level, that every economic man is a rational man, in which when he or she wants to make any kind of decision, he always compare between marginal benefit and marginal cost of taking certain decision. Okay, and here we are looking at the rational expectation. Now, it is a concept or modeling technique that is widely used in macroeconomics. Okay, so when a person or an individual try to make decision, okay, he or she will look at he or she will decide in such a way that it is usually depending on three things. Number one, his own rationality. Number two, information available to him. And number three, his own past experience, because most of the time our past experience to some extent can affect our current decision. Now, let's go to the basic model with exogenous expectation. So we want to come up with aggregate supply. We're going to use exogenous expectation, meaning that our expectation on price is exogenous. Expected price doesn't depends on any things in the system or in the function. Now, so like I said just now, we want to derive aggregate supply in terms of expectation. We know that, okay, in the aggregate supply analysis, when we talk about labor market in nominal term, in equilibrium, it is given by expression number one, in which on the left-hand side is nominal labor demand, okay, where actual price P is multiplied by labor demand and equals to, on the right-hand side, nominal labor supply, in which nominal labor supply is actually expected price here multiplied by labor supply. Okay, now, so let's say we normalize both P and PE, okay, actual price and expected price. So in particular, when we normalize, we equate it to 1. So when we equate it to 1, this one 1, this one 1. So our equation, 1 here becomes equation 3, in which Fn equal to a Gn. And next, given that we have normalized actual price and also expected price equal to 1, and given that we are in the initial equilibrium, we take the total differentiation of 1 to obtain expression 4, yeah? So how do we take the total differentiation of 1? Now let's go back to expression 1 here. So expression 1 is basically this. I write it again here. P times Fn equals to PE times Gn, isn't it? So you totally differentiate this one. Okay, so when you totally differentiate 1, it becomes Fn, okay, dP, isn't it, equals to price constant actual, okay, now, and then multiply by delta F over delta N times dN. Okay, now this is on the left hand side. Okay, we totally differentiate on the left hand side, so it becomes this. Now the formula to be used for this total differentiation is product rule. On the right hand side, we also have two terms, expected price and Gn, so we also use product rule to totally differentiate it. So it becomes Gn constant times dPe plus, okay, PE now constants times delta G over delta N times dN. Now, once you have this total differentiation, you rearrange it in such a way that the n on the left hand side and the rest on the right hand side here. Okay, then we can come out with 4. So where delta n over delta p is negative, Also, delta N over delta PE is also negative. Okay. Now, recall back, our objective is to derive aggregate supply. Okay, but using rational expectation model. Now, we have, we use production function, yeah, to convert 2 into a S curve. So here, it's not to convert 2, there's a mistake here. It is to convert 4 that we obtained just now into aggregate supply curve using expected, price. Now, how can we do that? So we have production function like this. So what you need to do is totally differentiate production function. So when you totally differentiate production function, on the left hand side, it becomes dy, isn't it? On the right hand side, you have n and k. Recall here, k is constant. So when we totally differentiate, then you can have this delta g over, okay, delta n times dn, isn't it? So we are doing for n. And then, it's not delta g, it's delta y. Delta y, okay, plus, okay, delta y over delta k, okay, times dk. However, this one we know no change, okay, so this one will vanish, okay, this one will vanish. All right, now once you have this, you rearrange it. You rearrange this total differentiation that you have done, the result that you have done here, such that the n on the left hand side and the rest on the right hand side. Okay, so when you rearrange it, you get number 6 here. Okay, so this is what you get. Now, so we have number 6. Also, we have number 4. Number 4 is dn equals to something. Number 6 is also dn, but equals to another thing. So you equate 4 and 6, yeah? And then after that, you rearrange them so that dy on the left hand side, the rest is on the right hand side, and it yields 7. Now, this kind of calculus, I won't show it to you because this is just a matter of cross multiplying left hand side to the right hand side and the other way around. So I won't show it to you. You must try it on your own. Okay, now, so we have seen that expected price here is exogenously determined, yeah. So any kind of change in expected price is not due to this, the variable within the system or equation itself. All right, now, so what is this actually, yeah? Expression 7, what is this? Okay, this is actually, aggregate supply in terms of equation with exogenous expected price. So this is actually, somehow the slope of aggregate supply. Okay, now let's try to look at in the form of graph. So if we try to put it in the form of graph, we have labor market. Okay, so we have N here, and we have W here. So you have, this is nominal wage, and then you have actual price P naught times Fn, labor demand, or MPN. Okay, Fn is actually MPN. And then we have labor supply, expected price times labor supply here. And then we have current wage rate, W, and then N here. Okay, now, and if we put in the form of production function, N here, so let's call this N naught. So this is production function, Y, N, K. Okay, so N naught is here, then Y naught here. So most of the time, you have seen the derivations of aggregate supply, aggregate demand, and whatnot in the form of mathematics. You'll see more advantages of knowing all of these things more in a bit. But now, what we want to do is we want to write aggregate supply equation here, which is in expression 7. Okay, expression 7 just now. Okay, with the explicit time subscripted from a form of expectation-oriented literature. All right. So in this case, what does it mean is that Okay, we are basically want to see it in the form of time period. Okay, so usually what we have here, consider that initial time is t minus 1, and then the next time period is t. Okay, so this one is more advanced than this one. Then the change in y, that is dy, in equation 7, yeah, is actually given by this. The output at time t minus the output at time t minus 1. Okay. Expression 9 shows you the change in the actual price level. In particular, GP equals to PT minus PT minus 1. PT refers to the price in current year. PT minus 1 refers to the price last year. Okay, all of them are actual price. Now, next, we have DPE. It is the change in expected price level, which is given by the difference between these two terms. Now, this one, you know already the price in PT last year. And then T minus 1 PT is actually the value of the price, this year that we already make the expectation in last year. So this is the expected price of this year. Okay. Now, and recall back that in equation 7, we have these terms. Okay, let's go back to equation 7, which is this. Okay, as you can see here, we have the first one here, which is the first circle here. Okay, this is what I'm referring to. And if you look at the second circle here, we have did it just now. Let's focus on the first circle here. The first circle here, rather than writing it many times like this, because it's it's quite tedious, so we can replace it with the coefficient beta. So this one is actually beta. Okay, now so here we have dy described as 8, dp described as 9, and dpe is described in 10 here. Okay, now we're going to use all 8, 9, and 10 to write it all of them in the form of expected value, or to write as equation in the form of expected value here. Now, what we have is dy, and then we replace the very tedious coefficient with coefficient beta, and then in bracket dp minus dpe. Okay, now dy, we already know that it is t minus yt minus 1, isn't it? Beta is beta. Now dp, we already know that pt minus pt minus 1, and then minus dpe. Okay, we already know that t minus 1 pt, okay, minus pt minus 1. Okay, and then you rearrange it until you get yt on the left hand side and the rest on the right hand side. There are some cancellation that we can do in this line, in this expression here, before we get 11. Yeah, now once we get 11, then this is what? This is actually as function that is written in the form of time. Okay, or better known as Lucas as function. Okay, so this is the mathematical expression of aggregate supply Lucas function. All right, but if you see here, once we have this, then we can collect data this year, we can collect data last year, and then we can collect data for actual price this year and expected price of next year. There is some correction here. This one should be PT only. Okay, delete minus 1 here. Now, can you see that expression 11 looks so familiar, isn't it? Because I'm sure most of you have or are studying econometrics right now. Most of the time, data is given this way rather than, in this form. Okay, now to make it looks like econometric, we add the arrow term on the right hand side here. Okay, we add the arrow term on the right hand side here. So once we have this, then it looks like, of course, obviously it is a regression line. Okay, now What does it mean by equation, 12 here or 11 here? How to interpret this function then? Okay, now especially 11, yeah, how to interpret it? Okay, this is the way to interpret it. Output this period, which is yt, yeah, will increase from initial equilibrium yt minus 1 by an amount proportional to the increase of price level pt relative to its expected level t minus 1 pt. That's how we interpret it. Okay. We can also use diagram to explain this expression here. In the form of graph, let's say we put price on the vertical axis, okay, and then we put output on the horizontal axis. Let's recall back, the equation looks like this. Yt equals to yt minus 1 plus beta, okay, and then pt minus t minus 1 pt, okay. Now here, aggregate supply function based on the slope that we have found is actually positive value. How do we know? Determine it yourself based on the information that is given in the early stage of this presentation or in the first few earlier slides. Okay, now, so we know that aggregate supply, output sloping. Now, because you put price on the vertical axis and y on the horizontal axis, well, usually in mathematics, we put y on the vertical axis. Why? Because price is the factor and the impact is on output, isn't it? Therefore, the slope here for this AS is actually equals to 1 over beta. But if we put the drawing like this, sorry, yeah. If we put the drawing like this, we put y here, price here instead. It's still up sloping, okay? But the slope here becomes what? Becomes beta. Okay, so it depends on the way you put which one is on the vertical axis, which one in the horizontal axis. Now, usually economics use this one. Okay, now let's pick one point on the aggregate supply curve. Let's call this point A, and then the current price is actually pt minus 1. The axis here, yt minus 1. So let's say we want to move along the AS supply curve or schedule. Let's say move from point A to point B. Then obviously the new y will be yt. The new price will be pt, isn't it? Okay. However, if let's say we want to hold yt minus 1 constant, yeah, but we want to move the price to pt, let's say here. So the price is pt, but the output stay the same, yt minus 1. So we call this point C. Is it on the same aggregate supply curve? No. It is obviously to the left of this aggregate supply curve. So aggregate supply curve shifts to the left, isn't it? When price increases from pt minus 1 to pt, holding income constant, then we shift output to the left. All right. You can try also, let's say we pick another point here. Let's say here, call it point D. Now this one, the price is pt minus 2. Okay, then it's going to be on another AS curve, isn't it? All right, so I shift to the right and on point D. Okay. Next, we move to aggregate demand. So let's first derive aggregate demand used in the static model. So we need to use IS and LM schedule to perform this task. Now, the use of IS and LM schedule, especially in the form of mathematics, has been many times explained in the previous classes, especially during the face-to-face classes time. Now, so here I just show you the step in doing it until you get expression 16. Yeah. So first, totally differentiate IS schedule. Label the results as equation 13. Okay. And then what do you need to do next is totally differentiate LM schedule. Okay, label the results as equation 14. Now rearrange equation 14 such that you have only dr on the left hand side, but everything else is should be on the right hand side. So step number 1 and step number 2 until this point, okay, and then label this expression as equation 15. All step number 1 and 2 this point up to this point here not something unfamiliar for you, yeah, because you have done this many times in during the face-to-face classes. Now, use this equation I mean, equation 15 here, okay, dr equal to something, isn't it? Now, in equation 13, where we have total differentiation of our schedule, you're gonna see dr, okay, on the right-hand side of equation 13 that you have found. So, dr that you have found in equation 15, substitute this dr back into equation 13. That's what it means by this statement. Use this equation in equation 13. Now, we need to normalize the initial price to unity or to 1 so that P not equals to 1. Then rearrange this equation until you get only dy on the left-hand side. Yeah? So, because our objective is to derive the aggregate demand expression. So, dy on the left-hand side like this, and then the rest is on the right-hand side. You should get something like this. Now, you see this bit, this is basically spending multiplier. And then you see here, in the square bracket, you have three things. Number 1, number 2, number 3. Now, number 1 here, you see DM, the change in real money supply. So, M, small letter m is actually capital letter M over P. This is money stock. This is price, yeah, actual price. Now, DG here is actually the change in government spending, real term. M, DP. M here is this. DP is the change in the actual price. Okay, now, from equation 16, okay, you can derive the slope of AD function. So you should get something like 17. Now, before you derive the slope of AD function, based on your basic study of AD, so you have price here, you have Y here, isn't it? So it is always downward sloping. So it means movement along the curve due to the price changes P0 to P1, then the output changes from Y0 to Y1. Okay, it's not about the shift in AD. Now you should know how to differentiate between the movement along the curve from point A to point B and the shift in AD from AD to AD prime. Now, what makes AD shift from AD to AD prime? Anything other than price. Okay, anything other than price. So let's go back to before we can derive slope of aggregate demand function in 17. You need to know the determinants of AD in the previous answer here in 16. So like I said earlier, this is multiplier, spending multiplier. You have three terms in the square bracket. Number 1, number 2, number 3. Okay. Output in AD can change due to these three terms. Number 1, number 2, number 3. Number 1, DM means what? The change in real money supply. Okay, number 2 is the change in G, government spending. Number 3 is the change in price here. So which one is more important? Obviously this. What should we do with DG? What should we do with DM? Obviously, in order to derive the slope of AD function from 16, in order to get 17, that's what I mean, you must make, set DG equal to 0 and DM equal to 0. Then you can get something like 17. But why do we need to set these two equal to 0? What does it mean here? Okay, so try to learn more about this. Now, once we reach 17, so we have derived the static model of AD. Okay, so this is just a static model of AD. We use actual price. Yeah, you can see DP here. And what about the expectations model of AD? Because in expectation model of AD, you have expected price. Okay, so then we need some assumptions. Yeah, so the assumption are here, no change in government spending. So DG is 0, isn't it? Okay, not only that. Okay, we have some other assumptions here. PT minus 1 is 1, MT minus 1 is 1. M, capital M here refers to nominal money. If it is small letter m, it is, nominal money divided by price, isn't it? Now, dy is YT minus YT minus 1. DP is PT minus 1. GM is MT minus MT minus 1. Okay, so you set all of these things. Now, so we can rewrite equation 16 in the expected form. Now, let's go back to equation 16 here. Okay, equation 16, on the left hand side we have dy. Okay, so dy is basically this, isn't it? If you can recall back, yt minus 1, isn't it? Okay, and now, not only that, okay, after you do some, simple calculus here, you should try, okay, from 16, with this assumption here, okay, you can write equation 16 in this expected form here, okay. Now, if you use all of this assumption here, put in 16 and then do some maths, bring to the left, bring to the right, you can get the equation 16 in expected form, because equation 16 itself is in static form. Okay, in the expectation form here, you can see theta is this, yeah, this is theta. Now, to get an answer in equation 18, you must do the calculus on your own. I won't show it to you because this is just a matter of substituting back into the equation, bring to the left, bring to the right, cross multiply, that's all. Okay, you need to practice it. Okay, now, so we have 18 here. Now, this 18 is expected form of, aggregate demand function. Now, we can also write this 18 in another form. Now, how to write this 18 in another form? Now, before we write 18 in another form, you look on the right-hand side of 18. We have two terms, the first one and the second one. Look at the first one here. So, this bit. Now, what can we do with this bit is that, okay, we can do something like this. Okay, we have this. Alpha is actually equivalent to theta, delta L over delta R over di over dr, delta R. Okay, so here, let's say alpha is defined by this. Okay, let's say alpha is defined by this, then we can have 20. Okay, we can have 20. On the left hand side is dy. On the right hand side is actually dp plus some other terms. Okay, so you see here, this is what I said to you just now. So if alpha is like this, then 1 minus alpha is actually the same as this value. Okay, this is just the reverse of this. Okay, now next, from 20, if we rearrange it again, so this is just a matter of rearranging the terms from left hand side to the right hand side and cross multiply, because it gives you some, very rich interpretation of different kind of thing in macroeconomics. So in 20, it's about the change in income, isn't it? But in 21, after you rearrange 20, then you can get 21, and you can also get 22. Okay, so you can see this term and this term here. And if I add mi t here, mi t refers to what? Then it becomes, it becomes error term. Okay, it becomes error term. Can you see when you transform static, expression of ADOAS into expectation form, okay, then you can see that you can relate the study of mathematics and the study of economic theory with econometrics that you have learned earlier. Okay, so this is how you connect theory to econometrics. After you connect theory to econometrics, then you can see, obviously, after you transform it to, the form which is much easier to understand in the form of expectation, okay, then you can see yt minus 1, mt, and also pt. All of this you can get data, because this is data for current year, this is data for last year, okay, and then this is data for price level, this is data for nominal money supply, okay. So then you can start running regression. So that is why, although you don't like theory, you still need to learn the theory, because otherwise you cannot try to understand when you come up with any kind of economic regression, okay, and then you just run the data using software, let's say eView or Stata. But if you don't know the meaning behind it, then the results that you get is meaningless. You can only interpret the results if you have the starting point, which is economic theory, that you must learn from scratch on how to derive it and whatnot. Okay. So AD in the form of graph is basically simple, because most of you have seen it when you did your principle of micro and also intermediate of micro. Now, okay, so price is on the vertical axis, on the horizontal axis is output, and then AD for a given nominal money supply. Okay, so just this is for a given nominal money supply. So just imagine, yeah, if nominal money supply increases, okay, then obviously AD will shift to the right from here to AD empty plus 1, for instance. Okay, so it shift to the right. So here, okay, you try to figure out the determinants of, AD, and then try to differentiate between the determinants of AD and also movement along the curve of AD here. Okay, we have derived the exogenous expectations equations for AS and AD previously. So now we can use both AS and AD that we have obtained earlier in order to obtain equilibrium income in an exogenous expectation model. Okay, so let's say we rewrite again AD and AS model in the expectations form. So AS is this one, 12, and also 22. Okay, so what we need to do is that you see PT here and you see PT here. So you substitute PT back into 12, and then you solve it, rearrange it, and then you can get, something like 23 here. And there's a correction here. You put a bracket here. All right. Okay. As you can see here, YT is on the left-hand side. Depends on the last year YT and depends on this term. So we have second term, first term, and the third term. Now the second term here, this is the coefficient, yeah, beta over 1 plus alpha beta. Now if you look at this, okay, this is basically what we call neutrality of money. Okay, and then if you see these two, MIT and ET, okay, if you recall back in the previous slide, epsilon here comes from as or aggregate supply curve. MIT here comes from AD. So both of them are basically error, okay, error. Okay, now what can we say about equation 23 here? It is actually the basic static model solution for YT, okay? And if you see here, it is in linear form because you don't see any power for, MT and also T minus 1 PT and also YT minus 1, isn't it? And also, so here we know that it is a linear form. So basically, it is a basic, static model solution for YT in its linearized Sargent-Wallace form with exogenous expectation. Okay, so it is we have Sargent-Wallace form of equilibrium, but this one is a linear form of its kind. Okay, now can we explain this in the form of diagram? Of course we can. So let's say I draw a simple diagram here. Okay, so we have YT here and we have PT here. So AD as a function of money supply. Okay, then we have AS as a function of expected price. Okay, so this is actually expected price, yeah. Okay, so initial situation, we have this and this, isn't it? So you have Y naught, B naught, for instance, at point A. So let's say you try to find any determinant. Let's say money supply increases. Obviously, money supply is the determinants of aggregate demand. So aggregate demand will shift to the right. Okay, from AD to AD prime, empty 1, for instance. Okay, so we can have increase in output, increase in price level. Now, what happens if expected price, okay, increases? Okay, if expected price increases, then it causes the real wage to falls down, basically. Yeah, the expected real wage to falls down. Okay, and then and then so on so forth. You try to figure out, yeah, because all of these things have been learned before. Then consequently, AS will shift to the left. Okay, AS will shift to the left. Okay, so from AS T minus 1 PT to AS prime, okay, T minus 1 P prime T, for instance. Okay, so we may stop here. Okay, so what you need to do here is that in order to see what happens to equilibrium price and output in the form of graph, you need to know the determinants of AD, you need to know the determinants of AS, you need to know what does it mean by movement along the curve for AD and AS. Okay, now, so here we have done the exogenous part. Now we want to find equilibrium income using endogenous expectation. Okay, so we know that from previous slides we have AS from 12, we have AD from 22. Now we want to use 12 and 22 to to write AS and AD with endogenous expectations. So what we need to do here is that we rewrite 12 and 22 by taking expectations of YT and PT. Okay, so we see we have YT here, we have PT here, we have PT here, and we have YT here. So when we rewrite it by taking expectation, you can see YT becomes T minus 1 YT, PT becomes T minus 1 PT. Okay, so same with this, becomes this becomes this. Okay, now after that, if we look at 24 here, okay, we can basically cancel this, 0, isn't it? So this one doesn't exist. Okay, so as a consequence, we can have something like this. Okay, T minus 1 YT equals to YT minus 1. What we need to do with this 26, we substitute 26 into 25, so that yields something like this. So you try at home how to get from 26 to 27 here, yeah, because it's not difficult. Now next we have 12 here, which is AS curve. We just substitute 12 into 22, which is AD curve. Why? Because we have YT here, substitute it here. All right, then we can have something like 28, but for 28 here we have some correction here. This is not YT minus 1, this should be T minus 1 YT. Okay, similarly this one also should be T minus 1 YT. Okay, now next, okay, so we have 28. Use this 27 into 28. Why? Because T minus 1 PT, you see this one, so it's equivalent to T minus 1 MT. So replace it, substitute it, okay, and then you can obtain 29. Okay, finally you rearrange equation 29 that you obtained just now, okay, so that you can get 30 here. So 30 here is equilibrium output with endogenous expectation. Okay, why we call it endogenous expectation, later you'll see more. Okay, now, so let us rewrite both of them again here to facilitate the comparison. Okay, so you have exogenous model, this one 24, and endogenous is this one. Okay, so you can see this one similar to this. Okay, this one similar to this one similar to this similar to this, and this similar to this. Now what makes it different is this bit. Okay, what makes it different is this bit. This is expected price. Okay, this is expected price that has been replaced by expected money supply. Okay, so that's why this one become endogenous, because we mix price here as and endogenous money supply here. Now, So 30 is basically a reduced form of YT with endogenous price as solution. Okay, now I want you to look at home the difference between exogenous and endogenous in detail. Now let's look at another thing that we need to emphasize here: basic equation on neutrality of money. Now the equation 30 that we have just now, which is this, okay. So we want to look at equation 30 to explain the neutrality of money concept. So have you heard the term neutrality of money concept? So this is equation 30, yeah. Okay, let's say there is an expansionary monetary policy. How neutrality of money can happen in this case? So how equation 30 can explain this situation? Okay, so you try to use 30 here to explain neutrality of money. Okay, so basically we know that, okay, if we have, for instance, we have here output, here interest rate, so here IS, here LM. Okay, and then we have initial R naught, and then Y naught, call it point E. You also can have, okay, I put here price here, so you have AD, and then you have AS, and then you have P naught, and then you have Y naught here. Y naught here is the same as Y naught in the first diagram. Now, so here, let's say there is an increase in money supply, or it is called expansionary monetary policy. Obviously, LM will shift to the right, isn't it? Then you can see interest rate falls down, output increases. Now, in the second graph here, because expansionary monetary policy means increases money, then it increases aggregate demand. Okay, to the right. Okay, so you can see output also increases, and at the same time price also increases. Okay, this only happens in the short run. However, after some time, which is in the medium run, actually when price has increased, yeah, price increase, you see here, price increase reduces the real money supply, isn't it? So LM will be affected in such a way that it may go back to the left. When it goes back to the left, all right, then you can see output is reduced, interest rate increases, isn't it? And in fact, not only that, yeah, when price increases, okay, it can also affect, this thing also, the second graph. How it affects, you try to figure it out. Okay, now, in the medium run, or most of the time we call it long run, okay, then you can see interest rate doesn't change at all because it goes back to R naught. Output doesn't change at all. But later, you'll figure out here, I want you to figure out, but in the medium run, okay, although interest rate doesn't change, output doesn't change, goes back to Y naught, okay, you will see price keep increasing. So here, you try to figure out how to make price increases based on the scenario that I have explained here. Now, in this case, all right, we have what we call neutrality of money. So money is neutral because as nominal money supply has no effect on output, you see here increase in money supply. Later on, after certain time in the medium run, it doesn't give any impact on interest rate and also output. Okay, increase in money supply is reflected in the increase in the price level proportionately. All right, so and here what I want you to do is that apart from checking what happens to price here, you look at 30, use this 30 and learn it how to explain neutrality of money using 30, yeah, because I've explained to you the basic here. Next, we want to look at one period contract and aggregate supply. So when we have contract in the labor market, it means what? That means wage rate is fixed because of the contract, yeah. So why do we have this assumption? I did mention to you just now. What is its relation with one period contract? I have explained it to you just now. So given that wage rate is fixed, labor market equilibrium is this. Can you see the difference between, this labor market equilibrium with the one when wage rate is not fixed? The one when wage rate is not fixed, we have learned it before, so try to compare and contrast. Okay, because in equilibrium in the previous classes, so we have PFN equals to PEGN, isn't it? And then equals to what? Then you figure it out. You go back to the previous notes. So for simplicity, let's assume the fixed wage rate is 1. The price at the initial period, let's say initial period is t minus 1. The price at the initial period is 1. Therefore, this implies that T1 becomes, this, isn't it? Okay. We want to obtain aggregate supply curve when which rate is fixed. So what we need to do is that we totally differentiate equation to 1 so that it becomes 33. Okay. How do we totally differentiate it? If you go back to equation 1 here, we have fixed wage equivalent to P times Fn. So this one becomes dW bar, isn't it? This one, totally differentiate this one first, keep this fixed, plus totally differentiate Fn, keeps price fixed. So we use, product rule to totally differentiate 31. So after that, when you use product rule to totally differentiate 31, you get what we have here, which is 33. And also for simplicity, this one is capital letter N, yeah? Assume this one equal to 1, okay? Assume this one also equal to 1 and rearrange 33 until you have the n on the left hand side and the rest on the right hand side. As you can see here, the sign is positive. How do you know it is positive? Because, this one on the denominator is actually negative. So how do you know it is positive? Try to figure it out. Now, recall back in the previous chapters when we learned about the, labor supply, employment, yeah, this is employment. When which rate is flexible, we have this, and you can see you have this, and you also have this, okay? So we have change in the expected price. We also have, the slope of labor supply. But why, when we have fixed wage rate, okay, we don't see, if you look at 34, when we have fixed wage rate, we don't see delta G over delta N, okay? We also see that, okay, DPE has been substituted by DW bar, okay, has been substituted by fixed wage rate. Now, I want you to figure it out, but actually, in the next slide, I'm going to show you the graph of all of this. From the graph, you can get the hint of why, all right, delta G over delta N doesn't appear anymore in 34, why DPE has been replaced by DW bar. Okay, let's look at the graph now. Now, in the form of graph, what we can do here is that we draw the graph here, okay, the labor market. So we have N here, and we have nominal wage, okay. So here we have initial labor demand, P naught, Fn. We also have the typical, labor supply that you learned before, PEGN, okay. Now, let's say equilibrium is at point A. If we follow the market, then employment is at N naught. Let's say which rate is fixed because of contract at W bar here. Now, let's say price increases, yeah, in the market. When price increases from P naught increases to P1, so this implies P1 is bigger than P naught. Obviously, labor demand will be affected first because you can see price. So P1 Fn. So you can see if we don't fix the wage rate, then you can have W increases to W1, employment increases to N1. But let's say after the increase in price, the wage rate is still fixed. You don't pay W1 because you have contract. You still pay a W bar. So where is the employment? Fix it, okay, and then you are here at N2. Can you see the employment is even more because wage rate has not increased. The cost of production hasn't increased. And can you see that? This is point B. At point C, okay, the equilibrium because of fixed wage rate it's not actually at the intersection between labor supply and also labor demand. Okay, so try to look at this diagram carefully and listen to my explanation just now on the diagram carefully, and then you may be able to answer why, okay, this one doesn't exist, this one has been substituted to dw bar. So good luck. We have not finished with the derivation of aggregate supply curve when we have one period which contract. This is just, the graph here shows you the equilibrium in labor market. Now, how can we relate this with aggregate supply? Let's say we have production function here in which you can see clearly, okay, the production function here, we have a constant capital y as a function of labor and fixed capital, and then we need to totally differentiate 5 and assume that fn equals to 1. So we're gonna have this. So you try at home first how to totally differentiate 5 so as to get 36 using this assumption. Now, once we have 36, okay, you use this 36 and substitute it back into 34 here, okay. So you have dn equal to dy. This is what I mean. Dy here now becomes, dn here now becomes dy. So it becomes 37. So dy equals to this. So can you see? Dy here is a function of dp. So this is actually the aggregate supply function when which rate is fixed, or when we have one period contract of which rate. Okay. Now, so what does it mean by equation 37? I have answered it just now. So basically when we talk about which rate contract, the results of one period which contract, okay, so when we have an anticipated increase in money supply, can produce an estimate of the expected price increase. So this will, leads to aggregate supply increase. Okay. Now, when actual increase in money supply happens, it shifts aggregate demand. Just imagine, yeah. Try to draw the graph, then you can see. Okay. So the two shift will be equal. So no change in dp at all. So no change in dp at all. Okay. So here again, I repeat. So first, okay, when we have one period wage contract, so here an anticipated increase in money supply can produce an estimate of the expected price increase. So as a consequence, this will, affect aggregate supply. Aggregate supply will increase. Why? Because of, the move in the wage contract. Okay, the move in aggregate supply. Okay, now when actual increase in money supply happens, it shift AD, of course, yeah, because money supply increase, AD increases. So we have two different effects here. One increase in AS, another one is increase in AD. The two shifts will be equal, yeah, in terms of proportion. So no change in DP at all. Okay, so here in this case, when there is no change in DP at all, therefore the consequence is one period contract is actually equivalent to flexible wage case, yeah, because it doesn't introduce enough rigidity. Okay, so it doesn't introduce enough rigidity to to make it different from the story of flexible wage contract. Flexible wage, sorry. Next, we want to look at contract wage and also price expectation. So what we need to do is that let the following take place in the economy. So DW wage, D wage bar is actually the difference between current contract wage and the last year contract wage, and this is 39. DP is as usual, you have seen this before. DY is as usual, you have seen this before. So we also have done this just now, 37. Okay, so you see here minus sign. So we have this number 1, number 2, number 3, number 4. Okay, now what we need to do with 37 is that write it in the expectation form. So when we need to write it in the expectation form, dy must be substituted by dy in 40, dp must be substituted by 39, dw bar must be substituted by 38. So after we do that, those substitution, then we can have something like this. Okay, now anyway, we shouldn't have double minus sign here. Okay, anyway, so this is 38. Now next, assume that PT minus 1 is 1. Assume that WT minus 1 is 1. So 38 boils down to 39. Okay, so here, if we look at this bit, okay, we can replace it by the term B prime. Okay, so here we can rearrange 29 so that we get something like this. YT equals to YT minus 1. And then what do we have? Plus beta prime in bracket PT minus WT bar plus arrow terms. Okay, now if I want to put it in the form of graph, it may look like this. Y, and then we have P, and aggregate supply is like this. Okay, so we have T minus 1 PT, but this time, okay, you can see the drawing is more or less like the one that we had before, but this time we have, one period wage contract. This one. Okay, so this is the aggregate supply curve for function when we allow one period wage contracts or fixed wage rate.